Hi people, I've been asked this question so many times, I might as well make a video for it. So look here, I have a ball. If I drop it from rest, um, which way will it go? It's going to drop straight down. It's just a vertical drop. Now what if I throw it sideways? So I give it a sideways push. Then it's going to do a parabolic path. Projectile motion, right? Now, what if I tie it to a string of this length and I hold on to this end of the string and then I give the ball a sideways push? Is this ball going to do circular motion instead? Well, it depends, right? If the initial speed is low, such that the original parabolic path that the ball is going to do look like this, then even if you tie it to a string that's of this length, the ball is still going to do the original projectile motion. The string has no problem whatsoever with the ball going this way. In fact, the ball is just going to tell the ball, hey ball, you do your projectile motion. I'm just going to slack here and watch you do your projectile motion. On the other hand, if the initial speed is large, such that the projectile motion that the ball is going to do looks like this, then we have a different story. Because this time around, the string is going to have a big issue with the ball going that way, because the string is tied to the ball and the string has to go where the ball goes. If the ball goes here, it means that the string is going to be longer. If the string has a fixed length, the string cannot allow the ball to end up there. So bo pian, the string has no choice. The string has to exert a downward tension force on the ball in order to force the ball to do a circular motion instead. So if the speed is low, the string will be slack and the ball ends up doing a parabolic motion. On the other hand, if the speed is high, there will be tension in the string and the ball ends up doing circular motion. So is there a critical speed, a gum-gum-ho speed, at which the ball will transit between projectile motion and circular motion? Of course there is. Let's assume that this ball is doing circular motion. So what are the forces that are providing the required centripetal force? The tension force and the weight. Applying Newton's second law on the ball, we can write T plus mg equals to the mass of the ball, which is m, times its acceleration. Since it's circular motion, we can write it as v squared divided by r. Now let's look at this equation. It's trying to tell us something. It's trying to tell us that the lower the speed, as the speed reduces, the tension will also be smaller because all the other terms are constants, right? So if v drops, t will also drop. But why, right? Why leh? The inertia of the ball wants it to go straight along the tangential direction. The gravity sort of comes in to help out. Gravity will make the ball do a projectile motion. So the tension force in the string must do the rest. The tension force must provide the remainder of the required centripetal force to make the ball do a circular motion. So the lower the speed, the smaller the momentum, and the smaller the required centripetal force to make the ball do a circular motion. So because of that, the string will not have to pull you that hard if you are going at a slower speed. So at the critical speed, the tension is going to drop to 0. I call it VC, the critical speed. This is the speed at which the string and the ball stop pulling each other. This is the speed at which the motion transitions between projectile and circular motion. Turns out the mass doesn't matter. The critical speed only depends on the length of the string and the acceleration of free fall. I guess that's all. Okay, ta-ta!